This is mathheals.com if you want to go here to get more links to math YouTube videos or computer science. Let's take a look at variation. It's kind of an introduction to variation. My brother was a business major going to college, and I kind of made fun of him, taking those real hard classes, handshaking 101, golf 102, and so forth. I was a computer science and math major. I studied pretty hard. One class I took in calculus, one assignment took me 10 hours to do. For the most part, he didn't study that much. He won't deny that. Did a lot of partying, and so forth. We both graduated. He always made twice as much as me. The degree of difficulty of class doesn't equate to how much money you're going to make. When I was making 20,000, he was making 40,000. When I was making 30,000, he was making 60,000. Now, if you looked at the relationship between our salaries, his name's Frank, and mine's David, of course. This is a relationship. So D for my salary, and then F would give you his. So if I plugged in 20,000 here, 2 times 20,000 give us 40,000. This is going to be represented by the letter K, and that's going to stand for a constant of proportionality. Now, these problems revolve around finding K. And in order to find K, you have to be given an example. Like if I told you I wanted you to find K between my salary and my boss's salary. Well, I'm not giving you enough information. I'd have to give you their salary and my salary. And then you could sit there and calculate K. Well, that's the same idea as this. Let me start a new page here. And let's take a look at solving variation problems. Our first step is to determine the type. There's direct variation, which is of this form. Y is equal to kx. This would be if I increased, let's say I started giving free points on tests. Just 20 points because I feel like it. Student doesn't have to do any work. Well, the student's happiness would go up. So as the number of free points goes up, the student's happiness goes up. There's an inverse relationship. If I decide I'm going to start assigning 100 more problems per section, well, student's happiness goes down. So as one goes up, the other one goes down. And that's of the form y is equal to k over x. There's a joint variation. Y is equal to kxz, where you got a couple different things working together to increase this. And then there's a combo, which is a mix of the above. Step 2. Pick variables that make sense. Usually x's and y's don't make sense. P for profit, C for cost. Pick variables that will click with you. Step 3. Look for the one example. Use it to solve for K. And plug K into your formula from step 2. Then step 4, find what they really want. So let's take a look at these. Let's look at our first problem. It says suppose that y is directly proportional to x. Well, it has the word direct in it, so this is a direct problem. And typically that's of the form y is equal to kx. Now, step 2 says pick variables that make sense, but actually we have x's and y's in this problem, so x's and y's actually make sense. So, don't need to do step 2. Step 3, look for one example. When x is equal to 5, then y is equal to 25. That's our one example. So, we got y is equal to kx, and they say when x is equal to 5, y is 25. So put 25 in for the y, and put 5 in for the x. And it says then use it to solve for and plug k. Solve for k. Okay, so we want to solve for k. So divide both sides by 5, and we get k is equal to 5. And then I say plug k into the formula from step 2. Well, we didn't have a step 2, but this was our formula. So we just said k was 5, so we got y is equal to 5x. Okay, step 4, find what they really want. It says find y when x is 7. So they want us to put in 7 for the x. 5 times 7, y would be 35. Let's look at our second example. It says suppose the y varies inversely with x. Well, this is an inverse problem. And that's typically of the form y is equal to k over x. Now we actually have x's and y's here, so those variables actually make sense. Step 2, pick variables that make sense. Step 3, look for your one example, use it to solve for k. When x is equal to 20, then y is equal to 8. So y is equal to 8 when x is 20. So put 8 in for y and 20 in for x. I want to solve for k, so I'll multiply both sides by 20. And those 20s cancel. And 20 times 8 gives us 160. Then we want to plug that into our formula from step 2. Well, k was 160, so we've got y is equal to 160 over x. In step 4, find what they really want. It says find y when x is 35. So they're telling us to put in 35 for the x. And, doesn't go into it evenly, I don't think. Top and bottom point, at least both divided by 5. So that gives us 3, 15, 10, 2, and 7. So y would be 32 over 7. Okay, let's look at another one. Suppose that y varies jointly with x and z. Well, that's a joint variation problem. And of course, x, y, and z's make sense here. Varies jointly with x and z. Step 3, look for your one example. When y is 30, then x is 4, and z is 3. Now we're going to use that to solve for k. 4 times 3 is 12, so we've got 12k. Divide both sides by 12. And 30 and 12 both divided by 6. So that gives us k is equal to 5 halves. So we'll plug that into our formula. So we've got y is equal to 5 halves xz. Now step 4, find what they really want. It says find y when x is 10. So plug in 10 for the x and z is 7. Well, this gives me 25 times 70. 2 and 10 both divisible by 2, which gives us 0, 5, 3, 1750. Assuming my basic math is good on that. 70. 70 seemed kind of big. I was just double checking. Going senile. Let's try that again. Okay, that should be 7. I was wondering why I would choose something that big. Okay, so that gives me 5. 25 times 7. 175. Let's see, 5, 3, 14. Yeah, 175. Assuming I didn't write another problem down or another number down wrong. Let's take a look at our fourth example. It says the daily profit P varies directly as the number of units sold in. Now this is a direct. Typically those are the form y is equal to kx. Step 2, pick variables that make sense. Daily profit P varies directly. The varies is where equals goes. So we've got P is equal to K. Varies directly as the number of units sold in. So they give us the variables. So K in. Look for your one example. If the profit is 41.31, so 41.31, when 810 units are sold, so N is 810. Now we want to solve for K, so we'll divide both sides by 810. So we got 41.31 divided by 810 equals K. And then we're going to plug that into our formula. So P is equal to 41.31 over 810 times N. Step 4, find what they really want. What is a profit? So what is P when only 520 units are sold? So they're telling us that N is 520. Let's see what that gives us. 41.31 divided by 810 times 520. And we get 2652. Okay, let's look at problem number 5. The gravitational attraction A between two masses varies inversely as the square of the distance between them. Now this is an inverse. Typically that's of the form y is equal to k over x. Pick variables that make sense. Gravitational attraction A between two masses varies. Varies is where equals goes, and they tell us to use A for gravitational attraction. So A is equal to, K is always up on top. Inversely is the square of the distance between them. Square of the distance. Well, that means D squared. I use D for distance. Step 3, look for your one example. The force of attraction is 13.1, so A is 13.1. When the masses are 10.2 feet apart, so D is 10.2 squared. Now we want to solve for K, so multiply both sides by 10.2 squared. And let's see what that gives us. 13.1 times 10.2 squared. Enter. And I get K is equal to 1362.924. And now we want to plug that into our formula. We know what K is. So we got A is equal to 1362.924 divided by d squared. Now step 4, find what they really want. It says, what is the attraction, so what is A, when the masses are 27.5 feet apart? So telling us to plug in 27.5 for D. Let's try it again. It's kind of sloppy. Even for me. So 27.5. So let's see what that gives us. 1362.924 divided by 27.5 squared. Enter. I'll take it 2 decimal places, I guess. 1.80. So A would be 1.80. Look at number 6. Gravitational field F varies directly with mass m and inversely is the distance squared. Well, this is a combo. There is no set form of the combo. You just write it down as you read it. The reason why it's combo is it says directly and inversely. Okay. The gravitational field F varies your equals, so F equals directly with the mass m, so we'll have Km, and inversely is the distance squared from the mass, so we'll have d squared down in the denominator. The inverse part always goes in the denominator, so if it says inversely is this, then that's the part that goes in your denominator. Step 3. Let's see, look for your one example. If a mass of 200, so they're telling us m is 200, and a distance of 5, so 5 squared, give a gravitational field of 80. So F was F for, yeah, F was gravitational field. Okay, so let's solve for K. So we got 200K over 5 squared is 25. 200 divided by 25 gives us 8, so we got 8K. Divide both sides by 8, and we get K is equal to 10. So we'll plug that in here. So we got F is equal to 10m over d squared. Now find what they really want. It says, what is a gravitational field? What is F? When the mass is 310, so m is 310, and the distance is 7. So we got 7 squared. Let's see. 10 times 310 divided by 7 squared. I'll take it 2 decimal places, I guess. 63.27. And that's our answer. Let's see, problem number 7. It says the weekly payroll P in dollars as a small factor varies jointly as number N of men employed, number D of days that they work. So it's a joint variation. We've got Y is equal to KXZ. Typically. You can have more than 2 though. See, weekly payroll P in dollars at a small factory varies where equals goes. So this is P equals K and as a number N of men employed. So N for the number of men employed. And number D of days that they work. So D of days. Step 3, look for your one example. Use it to find K. When 30 men, so N is 30, worked 5 days each, so D is 5. Payroll was 2,000. Well, let's use that to find K. 30 times 5 is 150K. Divide both sides by 150, and we get 2,000 over 150. equals K. Now you can simplify that if you want, but we're going to end up putting it up in our calculator anyway, so you might as well just leave it as is. So K is now 2,000 over 150, and then ND. Well, step 4, find what they really want. Find a payroll, so find P. When 42 men, so N is 42, work 2 days each. So let's see what that gives us. 2,000 divided by 150 times 42 times 2. Enter. And we get 1120. And that would be our answer. Now I pulled this out of a real old college algebra book, and you can kind of look at it and see. Factory, I'm not even sure if they refer to those as factories anymore. And then it says all men. You know, it doesn't refer to women at all. So it must have been like before World War II. And then look at the salary. When 30 men worked 5 days each, the payroll was 2,000. Companies love to have that now for their payroll. And anyway, that's the end of that section. So let me go ahead and save this.